So in this lecture, I'm going to show you the mathematical expressions for the time of flight, maximum height, and then the range of a projectile motion. Okay, so let us start with the time taken to reach the maximum height. The time taken it takes the projectile to reach the maximum height. So the time taken is given by the formula T is equal to U sine theta over G, where U is the initial velocity, okay? Theta is the angle of projection, and G is the acceleration due to gravity. Okay, so this is the formula to calculate the time taken for a projectile to reach the maximum height. Right? We can also consider the time of flight. And we said in our previous lecture that the time of flight of a projectile is actually the time taken to cover the horizontal range, and it can be calculated as T is equal to 2U sine theta over G, where U still remains the initial velocity and G is the acceleration due to gravity. Of course, theta is still the angle of the projection. So we can also have the expression for the maximum height. Maximum height attained by the projection is represented as capital letter H, which is equal to U square sine square theta over 2G, or we can say H is also equal to U squared sine theta squared all over 2G. They are still going to give you the same answer. Okay, so this is the formula for calculating the maximum height of a projectile, and the final formula we need here is the formula for calculating the range, R. This is equal to U square sine 2 theta over G. So these are the formulas you can use to solve problems under the projectile motion. In fact, these are the major formulas. Let me not just say formulas, okay, because we have some other formulas we can use, but these are the major formulas to solve problems under projectile motion based on what you're asked to look for. Is that okay? Let us consider one example before we end the class for today. A body is projected from the ground at an angle of theta to the horizontal with a velocity of 30 meters per second. The body reached a maximum height of 11.25 meters. Calculate the value of the theta. We also have to calculate the time taken to strike the ground and also the range. Then we have to take G to be equal to 10 meters per second. So since we know the formulas for the range, time of flight, time taken, and the rest, we can apply them into solving this problem. So let us consider the first case. The problem is to find the value of theta, but we know that because we have already been given the maximum height, we can calculate our theta from it. Remember that H is equal to U square sine square theta over 2G. We have the value for U, we have the value for G, and we have H, so we can calculate the value for our theta. Okay, so H, which is 11.25 from the problem, from the question, is equal to U squared is 30 squared sine square theta over 2 times 10. Okay, this is equal to 900 sine square theta over 20. If I cross multiply, I have that 11.25 times 20 is equal to 900 sine square theta. So dividing through by 900, I have that sine square theta is equal to, of course, this will cancel out. So this is equal to 0.25. Sine square theta is the same thing as saying sine theta squared, okay, equals 0.25. So if I find the square root of both sides such that this will cancel out. I'm left with sine theta is equal to 0.5. Therefore, theta will be equal to sine inverse. Therefore, theta is equal to sine inverse of 0.5. And we finally have theta to be equal to 30 degrees. So this is the value for theta. That's the answer to the first problem. The second question requires that we find the time taken to strike the ground. The time taken to strike the ground is given by the formula. Okay, the second one, T is equal to 2u sine theta over g. Why is it 2u sine theta over g? Because the time taken to hit the ground is also equal to the time of flight. And we have this to be equal to 2 times 30 times sine 30 over 10. So this gives 60 times 0.5 over 10, which is equal to 3 seconds. So the time taken for the projectile to hit the ground or to strike the ground is equal to 2 seconds. And finally, we have to find the horizontal range. And the formula for horizontal range is u squared sine 2 theta over g. So what is our u squared? This is 30 squared times sine 2 times theta was calculated as 30. So sine 30 all over 10. This is 900 times sine 60 over 10. This gives us 90 times sine 60. So if you obtain the value, realize that the horizontal range is equal to 77.94 meters. And this is our final answer. So therefore, given the parameters, our theta is equal to 30 degrees. Our theta is equal to 30 degrees. And the time taken to strike the ground gave us 3 seconds. And of course, the horizontal range is equal to 77.94 meters. So this is how to apply the formula. The most important thing is for you to know your formulas and how to substitute your values and then apply the parameters we have into the equations, and then your answers will just be there glaring at you. So this is the end of today's class on the applications of the projectile motions or problem solving approaches in projectile motion. So this is where we wrap it up for today's class. If you have problems or you still have issues, you still have worries based on the topic we just discussed, you can drop them on the platform at www.awoko.ng, where we are going to attend to them as soon as we see them. Till we meet again, bye for now.